equations of tangent lines. So yesterday we learned that the equation or that a tangent line at a point is a derivative. So to write the equation of a tangent line, you have to first find the derivative. So you are first going to find f prime. And that will give you the slope at a point. Okay, then you're going to use point slope form to write the equation of the tangent lines. We are also going to learn two alternate forms to the derivative that might make finding the derivative at a point easier. Okay, so yesterday we learned that the derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. That is the derivative of any, like, at any point. And then we learned that we would plug in the x value to get the derivative at that exact point. Well, we can also find the derivative at a point. So c would be like a value of x instead of just x. By finding the limit as x approaches c, so as x approaches a number of f of x minus f of c, so it's still slope, change in y over change in x. That will give you the derivative at a point. Another version of it is the limit as h goes to 0 of f of c plus h minus f of c all over h. So c is like a number. So I'm going to show you these alternate forms so you can see how you can find the derivative. And then we'll also associate it back to what we did yesterday, and you can also use that method. So these forms might be used if you're asked to find a derivative at a single point. So here we're going to find the slope of the tangent lines. So slope of the tangent line, that means that you are finding the derivative. And we want to find it at the zeros. So zeros are the x-intercepts. So first, we have to find the x-intercepts. So if I have x squared minus 4, I'm going to go up to the side, x squared minus 4. I want to find where it equals 0. Where does it equal 0? 2 and negative 2. All right, next I want to find the derivative. So I'm going to show you this alternate form of the, or maybe I'll do it. Let's do like we did yesterday. For those people who weren't here yesterday, let's do definition of derivative. So I want to find f prime of x. So yesterday we learned the derivative is the limit as x, no, as h approaches 0. Sorry. As h approaches 0 of f of x plus h. So in for the x, you're putting x plus h. F of x plus h minus f of x, and you need parentheses. Some of us learned that the hard way today. All over h. You weren't down there. And now we have to simplify. So I'm going to multiply that out. So that would give me x squared plus 2xh plus h squared minus 4. Now I'm going to distribute the negative all over h. Okay, so I FOILed it out, distributed negatives. Let's see what I can cancel. I can cancel x squared and x squared. -4 and +4. The limit as h goes to 0 of 2xh plus h squared all over h. I still, if I evaluate that limit, I'm gonna get 0 over 0. So I can reduce it, and that's because this term, and the bottom all have what in common? H. So I'm gonna cancel out an h. So I get the limit as h goes to 0 of 2x plus h. I'm just wiping out an h from each green circle. Now, when I evaluate the limit, I plug in 0 for the h, and I get 2x. So that tells me that the derivative is equal to 2x. Okay, that's what we learned yesterday. Today, they want us to find the slope of the tangent. So we want to find the derivative at these x values. So that means I want to take those x values and plug them into the derivative. So I want to find, I know I'm kind of running out of space here. You're probably running out of even more space. So I want to find the derivative at 2. So when I plug 2 into 2x, I get 4. And then I want to find the derivative at -2. So when I plug in -2, I get -4. So that means if I were to graph this x squared minus 4, let's have parabola move down 4 like that. Right here, this tangent line has a slope of 4. Oh my God, making all kinds of mistakes here. And over at this 0, that slope of the tangent is -4. Right, so basically the same thing we did yesterday, we're just plugging in x values. All right, questions on that one? Now, the next one, I'm going to show you that alternate form. I personally like the first alternate form. I like this one better. But I'm going to show you, because this one basically is doing the long way, just with a number. So I'm going to focus on that first one for this next example. So, all right. Find the equation of the tangent line at x equals 3. So if I want to write the equation of a line, what are 2 pieces of information that I need? What do you need to write the equation of a line? Slope and a point. So we need to find the slope and we need to find the point. Those are 2 pieces of information we always need to write the equation of the line. So because we're writing the equation of the tangent line, the slope is the derivative at that x value. So we have to figure out what that is. The point is just plugging 3 into the original function. So if I find f of 3, it's just 3 squared, which is 9. So I have the point 3, 9. Okay, so now we have to focus on, we haven't found the slope. So I'm finding the derivative at 3. So I'm going to use that alternate form. So I'm finding the derivative at 3 is equal to the limit as x approaches c, which is 3, of f of x minus f of c, well, my c is 3, all over x minus c. So wherever I saw c, I replaced it with 3, because that's what I'm finding the derivative of. So simplifying this, the limit as x approaches, not simplifying, let's plug in f of x. So what is f of x? X squared minus, what was f of 3? 9, all over x minus 3. Well, if I plug in, I get 0 over 0. Try harder. How am I going to try harder? Factor and cancel. So how about if I just write above? This is going to factor to x plus 3, x minus 3. And so the x minus 3s are going to cancel. So my derivative at 3 is equal to the limit as x approaches 3 of my reduced function, which is x plus 3. And when I plug in 3, what do I get? 6. So what is the slope? When I come back up here, my slope is 6. Okay, so now I have a slope of 6 and I have a point. How do I write a tangent line? I do point slope. So y minus 9 equals mx minus x. And that is the equation of the tangent line at x equals. What's wrong? Nothing? Yes. How's it going?
Oh, I think that is like that's
Okay, so this right here is from up here, which is the alternate form of a derivative. Now, could I have done what we did in example 1 and found the derivative and then plugged in 3? Yes. You can do it either way. So yesterday, we found the derivative of x squared. That was the very first example we did in yesterday's notes, and we found it to be 2x. So if I plug in 3 into 2x, that's going to give me 6. So you can do it multiple ways to get the same answer.
So this is the short thing you find out.
This I think is a little bit shorter when you're finding the derivative at a point. But it's personal preference. All right, questions on that? All right, let's try the next one. It's a little harder here. All right, so find the equation of a line tangent to this graph that's parallel to another graph. So I'm going to give you a little visual because I think this question's a little confusing. So if I have 2x squared, it looks like that. If I take this line and solve it for y, it's going to be what? Negative 4x minus 3. So if I take this line, going to look something like that. So what I'm trying to do is I'm trying to find a point on here where I can make a tangent line that's parallel to that blue line. All right, so that's my goal, is to figure out what is this green line. So if they are parallel, what does that mean about their slopes? Same slopes. So okay, so my tangent line, how do I find the slope of a tangent line? Slope is equal to the derivative. Yes. Well, we want the slope of f prime. So we want f prime of x to equal the slope of the line that's parallel. So what's the slope of this? In my picture, the blue line, -4. So I want to know where is the derivative equal to -4? That's going to give me this point right here. So I have to find the derivative of f. So we're going to practice till we get really good at derivative. So how do I find the derivative? Limit h goes to 0, f of x plus h minus f of x all over h. Are we getting better at algebra yet? No, because I'm doing it and you're just copying it. Okay, I'm gonna FOIL and distribute the two at the same time. I'm gonna get 2x squared plus 4xh plus 2h squared minus 2x squared all over h. What did I, do you have a question? No?
Not right.
So 2x squared minus 2x squared cancels out. Do you see that I'm going to be able to reduce an h also? Yes. So my derivative is the limit as h goes to 0 of 4x plus 2h. When I plug in 0 for h, I just get 4x. So I'm going to come back to here. And in place of my derivative, what did I just find the derivative to be? 4x. So I want to know, where does 4x equal -4? At x equals -1. So that means up here on my graph, this ordered pair is -1. What would the y coordinate be? You would have to do 2 -1 squared, which is 2. So I have the point -1, 2. There's my point, but I'm writing the equation of a line. What else do I need? Slope. What's my slope? Can I write it as m instead of the word slope? Slope is -4 because they were parallel. So now the equation is just y minus 2 equals m x minus -1. So there's your tangent line. So that's the equation of the green line in my picture. I don't like that I wrote green and red.
For x equals -4, it's the primary point.
All right, so recap, what we were finding, we were trying to find this green line in the picture. They gave us the blue line. So this here is that blue line in my picture. So I knew that they were going to be parallel. So if I have the same slopes, well, the slope of a tangent line is the derivative. So that's why I set f prime, because that is the slope of a tangent line. You automatically, when I say derivative, you think slope of tangent line. Slope of the tangent line had to equal the slope of the blue line, because they're parallel. And so then I had to do some math to figure out what the derivative was before I could find the x value.
Oh, that's 4x, the derivative is equal to -4.
the derivative is 4x, and I
You
set
the
that.
derivative equals the slope of the one equation.
Yes, yep. I think there's one like this on your website. So you'll be able to practice and use the example. All right, so that's the hardest one, I think, we're gonna do today.
You get a point with that by setting the derivative equal to the slope.
Derivative equal to slope, that gives you the x value.
And then you plug.
And then we plugged this into f of x, which is 2x squared. And that's where I got the 2.
How do you know which function you plug the derivative?
Because I want the point on the function.
No, okay.
Okay, any other questions? All right, now let's go a little bit easier. Find the derivative at x equals 1. And f of x is x squared plus 2x. So I'm gonna use that alternate form again because I think it's easier. So I'm gonna say I want to find f prime at 1. So because it's at a number and not x, I'm gonna use that alternate form, which is the limit as x approaches 1 of f of x minus f of 1 all over x minus 1. That is just the definition of derivative at a point. So now f of x is this quadratic minus, what is f of 1? So take 1 and plug it into f, and what do you get? 3 all over x minus 1. You get 0 over 0, which means try harder. How are we going to try harder? Factor and cancel. So what does it factor to? X plus 2, x minus 1. So those cancel. And then when I plug in my 1 for my limit, I get what? X. Oh my gosh. What in the world? Thank you for paying attention. X plus 3, x minus 1, is that better?
Yes.
Okay, but the x minus 1's cancel. Now when I plug in 1, what do I get? 4. So the derivative of f at 1 is 4. What does that mean? If I graph that function at 1, if I draw a tangent line, the slope is 4. All right, you ready to try one on your own?
Yes.
Okay, we're writing an equation of a tangent line. Equation of a tangent line, so you need a point and you need a slope. Luckily, they gave you the point, so you need to do the work to find the slope. Go ahead, I'll give you a few minutes. So what I wrote up here are the three definitions of derivative, the three ways you could have found the derivative at two. Okay, the first way is finding the derivative. And then you would plug in two. The second way is the one I've been doing. And the last one was that third definition that I haven't showed you yet, which was the limit as h approaches 0 of c plus h, sorry, f of c plus h minus f of c all over h. All of them are going to give you the same answer. Raise your hand if you did the middle one. Raise your hand if you did the first one and then plugged in. Okay, so we have multiple ways. Oh, no, that's not nice.
Guess what I got? Guess. Yeah. So. The first one, right? So I need to learn first. You like this. It's only what you can find it. Is it not like it's not as like when you get over top? So that's. You got it. Yes.
Okay, so your derivative is 12, however you got it. If you did it the top way, you should have gotten f prime of x to be 3x squared. And then so that would have given you this, and then when you plug in 2, you get 3 times 4, which is 12. So my final answer is going to be y minus 11 equals 12, x minus 2. Okay, this one, the reason why I don't like this one is because you end up having to do like the same thing as the first one. It's just with h's instead of x's and h's, but this would also give you 12 if you worked it out. Here we had to remember cubes, how to factor cubes so that we could cancel. All right, questions on that? All right, oops, sorry. The next one, I think the problem went onto the back, but you have the question at the front. So if you just want to like rewrite this piecewise function on the front of your notes, you could, so that you have. So we're going to show using the definition of a derivative that the derivative does not exist at x equals 1. All right, so this is our. I'll give you a minute to copy that onto. Remember yesterday how we said a function can be continuous, but it doesn't necessarily mean that it's differentiable, that we can find the derivative. This problem, if I plug 1 into that, what do I get? 1/2. And if I plug 1 into here, what do I get? 1/2. So this graph is continuous, but we want to know, we're showing that the derivative does not exist at 1. Okay, so how do I find, I'm going to use both sides here. How do I find the derivative at 1? Yes. So we have to find the derivative of both sides because it splits at one. So let's look at which one's on the top. So one approaching from the left. So I'm just gonna say that I'm approaching one from the left and finding the derivative. I'm gonna use that alternate form. So I'm gonna say the derivative as I approach one from the left is equal to the limit as x approaches one from the left of f of x, which is 1/2 x squared, minus f of one, which you told me was 1/2, all over x minus one. So I have to do a little algebra. What can I factor out of the top? 1/2. So when I bring out a 1/2, what am I gonna be left with? X squared minus one. Are you okay with me factoring that as difference of squares? Okay, so it's gonna become x plus one, x minus one, and then that x minus one on the bottom. So I can cancel those. Where'd I get the x plus one, x minus one? When I factored out x squared, I factored out a 1/2 and then I got difference. So I just changed that to x plus one, x minus one. All right, so when I plug in, what is my derivative as I approach one from the left? One. Oh, it's the definition of derivative. So this is limit as x approaches c, f of x minus f of c, all over x minus c. That's what I'm using. C is one, yes. Because this is a quadratic. And so when I go up to one, if I take the slope of that tangent line, it's one. Right? Because when I put one in here, that gives me two, and 2 times 1/2 is 1. Yep. All right, so now I'm gonna go to the other side. And I'm gonna find the derivative. Is that blue okay? Hold on. Or no? Are you sure? Okay. One from the right, so I'm gonna use this same form. So I'm gonna find the limit as x approaches one from the right. So what function is that? It's the bottom one, which is negative 1/2 x plus one minus f of one. So f of one was, I already forgot, 1/2. All over x minus one. Let's do a little math here. Limit as x approaches one from the right. And that's gonna be negative 1/2 x plus 1/2. I can factor out a negative 1/2. Oh my goodness. Did not give you enough room, did I? When you do that, the x minus ones cancel. And my answer is just negative 1/2. So the derivative as I approach one from the right is negative 1/2. And the derivative as I approach one from the left is 1. So that is showing that the derivative at 1 does not exist. So what's happening there is you kind of have a sharp turn. You have a parabola. And then maybe a line that like does that. So they meet, but it creates a sharp turn at that value. Ooh. I think I'll show the other ones the short version.
what would you say? It's continuous, but
not differentiable. So this graph is continuous at one, but not differentiable at one.
All the kids on one side.
all differentiable are not continuous.
Correct. Yep.
Okay.
All right, the next two, I'm gonna pretend that these are multiple choice questions. Okay, if it's a multiple choice question, you don't have to properly show your math, but you have to understand what you're doing, okay? So I'm gonna look at this graph. Absolute value of X looks like that, right? So this side is really Y equals X. And this side is Y equals negative X.
Yes.
So yesterday, we learned derivative of linear functions is what? The slopes. So when I look at this piece, what is the derivative of that piece? What's the slope of this line? 1. What is the slope of the other side? -1. So at 0, the derivative on one side and the derivative on the other is different. So that is why the derivative does not exist at 0. -1 does not equal 1.
You can just contract it.
So this is if it's multiple choice and we don't have to properly show. This would be like an FRQ where you have to show the process that you're taking to get there. All right, so this one, here's a next example. If I plug in 0, that gives me 0. If I plug in 0 here, that gives me 0. So that means F is continuous. All right, then I'm going to look at the derivative of F. Since we have already, I think twice, found the derivative of X squared. What was the derivative of X squared? 2X. So the derivative of the top function was 2X. The bottom function is a line. So what would the derivative of that one be? 2. Okay, so what I'm doing is I'm taking the derivative of the top function, the derivative of the bottom function. And now what happens if I plug 0 into the derivative and 0 into the derivative? I get 0 on the top one and 2 on the bottom, which is not equal. So that means that F, I'll write it over here. F of X is not differentiable at X equals 0. So F is continuous at X equals 0, but it's not differentiable. So that's how you can kind of show the shortened way. Not really shortened.
2x.
All right, the last thing we're going to cover is how to find derivatives at a point on your calculator. Okay, so if it's calculator active, so go ahead and take your calculators out.
Yeah, on that one. So, what is this? That's not open. Shut up. Can I?
Well, you, something is on the.
Oh, I need this. No. Yes.
All right. So real fast, we're just gonna do this example for where we were finding the derivative at x equals 1 for f of x equals x squared plus 2x. We found the answer to be 4. So I'm just gonna show you, I'll first show you on the 84. So if I go to my 84, there's 2 ways to do it. The first way is you can go to math. And number 8 says n derivative, n deriv. So if I go to number 8 and hit enter, mine pops up using this notation of dy over dx. So in the blank here, I need to put an x. What's next to it is the function because it's dy. So y is your function. So what was our function? X squared plus 2x, was it? Plus 2x. And then if you hit the over arrow, it's asking what x value do you want to find the derivative at? And we found it at 1. And when I hit enter, it gives me 4. Okay. That's it.
Does that?
The second way, what you can do is you can go to y equals, and you can graph an equation of the derivative. So again, I go to math, I choose number 8, I put in an x, I put my function, which was x squared plus 2x. And then here, instead of a number, x equals a number, I'm gonna put x equals x. And when I hit graph, it's graphing the entire derivative, the equation of the derivative. So then if I hit trace and say, what was the derivative at 1? It gives me 4. Okay, NumWorks calculators. We have NumWorks in here. Okay, NumWorks.
Yeah.
You are gonna go to the calculations. Then click your toolbox right here. When you click toolbox, one of the options is calculus. Find the menu that says calculus, hit the arrow, and then derivative, and then you type it in the same way as the 84.
And I think there's a template for graphing it too, where it has the implementation. And you can put it display values and then type in.
Oh, sweet. I haven't figured that out yet. All right. I think that's it for the notes. There's just some more practice problems for those of you that are still struggling with some health practice. All right, so that is it for the notes.
It's like the first part. Got it. So his. This is the guy.